Um, and then it kind of briefly goes through all of the steps, and a lot of these steps are what we're going to be doing for the rest of the semester in much more detail and via practice as well, not just talking about them. So one of the key things to understand with the distinction of what we're going to cover in this class and what you may have experienced before is really boils down to scope and scale. You guys, I'm assuming, have probably developed applications of some kind in other classes. Maybe you had a Java application that you made, or Python, or something like that, and you had relatively discrete problem sets that you were given that you had to solve. Of course, you may have solved that with some time on Stack Exchange, or and I'm not judging you too harsh, because that's what a lot of people do in the professional world as well. It's not like Google is blocked. I will say, though, my first job as a developer, they actually did block the internet. And it was astounding to me, even back then. This is admittedly the last millennium, the last century. It was 1999 that I had my first job. But they had an intranet we're allowed to use with a help thing, which was terrible. And they were so worried that we would be wasting time on the internet that they blocked it. So that wasn't fun. It made for much longer development times. But anyway, this scope and scale is so far beyond what you may have developed before that any experience you have as a developer really only scratches the surface as to what you might have to do when you're building a true information system. So it says in that first point, this text is about developing information systems that solve an organization's needs, it should say. So an organization's needs can be large and complex. You may have thousands of users. You may have a lot of different levels of access that are needed. You may have complicated interacting pieces of data that you have to be very cautious about not having duplication of that data, because what happens with duplication is you end up with errors that can hurt either the customer or yourself. Let me ask a quick question curricular-wise, because I actually don't know. I haven't been here long enough. Those of you in information science or information systems, or even computer science for that matter, is database a required class for you to take? It's an elective. Okay. Who has taken database? Taking it now, so running along with it. A lot of you are in that boat. You're taking it now. Okay. Well, not a lot of you. 4 of you. Okay. That's interesting, because for an organization, data really is one of the core elements that you're working with. The process is honestly secondary to the data. And by process, I'm talking about the logic that you would write in the code. The data is of prime importance. So we're going to probably spend some time in here talking about databases and talking about how to develop it, because not all of you are taking the class right now. So you'll get kind of a shorthand view on development within a relational database system. All right, so as I said before, this first chapter, it goes through kind of a shorthand development of a smaller information system. Again, something you might be familiar with, developing a small application. And then as the textbook goes on, we go into much more detail, and the types of systems we'll be building will become larger and more complex, and you'll start to see the value as to this process that we're doing in analysis and design. Now, I do know that developers hate documentation. To them, it's, for the most part, it's busy work. It's extra stuff that you have to do. I want to solve the problem writing the code, is what a lot of developers say. So this is the epitome of something developers don't like to do. But I'm hoping by the time we get to the end, you'll see there is actually a lot of value in this. So here we have our 2 distinctions that I've said before. So your basic computer application, and it's a very limited set of functions that you would want with a computer application that's not necessarily supposed to be running an entire organization. Something that you might see on a phone, something that has a particular task in mind, like word processing, browsing on the internet with the HTTP protocol. Things like that are computer applications. An information system, on the other hand, this is a set of interrelated components that collects, processes, stores, and provides as output the information needed to complete business tasks. It's a lot of words. What does it actually mean? It means every business is unique with its own set of processes, its own set of data, and if you want to technically implement a solution to that social system, remember we talked about that on the first day? What is an information system? It's a social system. You have to collect all of what are called business requirements. All of the things that make up that business. You have to analyze that. You have to make sure it's thorough. You have to make sure you have every perspective. You have to make sure you're not missing anything. You have to make sure that people can trust that when they tell you there's a problem or there's something they wish was done differently, that you're going to listen to them and you're going to make the adjustments needed. Then you have to turn that into a plan for the developers. They have to know exactly what to code when it comes time to do it. Now, admittedly, what I just described to you is a little bit of an old school view. A little bit of an old school view. Nowadays, there's a lot of options companies have. They better do an analysis one way or the other. They better know, I better understand me before I try to solve whatever my issues are. But what used to be the norm of having a team, an internal team of developers to do it, while that still happens, it's not the only solution anymore. Nowadays, you might send that the design specs out to some company in India, or China, or Vietnam, or any one of the big offshoring places. You might contract with a company down the road to create it for you. You might say, this is really similar to an off-the-shelf product that I saw, and if we could just make some tweaks to it, we can make that fit here and we won't have to do any development. We just have to pay them a licensing fee. Those are often called enterprise systems. So there are a lot of other options, but the analysis and design, regardless of what solution you choose for the implementation, the analysis and design should always happen. And unfortunately, it doesn't. You guys may not know the answer to this, but maybe throw a guess my way. What do you think the failure rate is for new information systems today, 2020, on average? It's getting there. It's getting there. It's a little bit of a trick question. The trick being, what does failure mean? That should have been your first question to me. What do you mean by failure? Because I think when I said the word failure, what a lot of you pictured was literally crashing and burning, nothing comes out, and oh my gosh, we just wasted $100 million trying to develop this. That is a form of failure, yes. It's a very bad one. It's not the only form of failure, though. What if I only get 25% functionality of a system that was intended to have A, B, C, and D, and I only got A completed in the allotted time frame? Is that a failure? Probably. You'd have to do some financial analysis and determine, am I still making some type of profit off of that 25%? Is it functional in its own way? Have we automated things? So there's some questions to ask. It's a little muddy when we start getting there. What about this? What if I had 90% functionality, but it took me 3 years to do it instead of my 1 year that I'd allocated? Is that a failure? In a way, it is also a failure. So be careful when you say failure rates, because it can mean a lot of things. So including all of those, it's at 65%. 65% of all new IS projects fail in one degree or another. Total abject failure is around 20%. 2020. What about 1970? No one wants to throw a guess out, because I know you don't know off the top of your head. This is one of those what's the last question of the Who Wants to Be a Millionaire thing, where there's just no way anyone could ever actually know that. No, good guess. You would have thought it would have been worse. We've been slowly improving. A very optimistic view on humanity. I appreciate you. It's actually the same. And I don't like that, because we as humans, we want a story, right? We want to know, like he in his mind, he had a story like, things were terrible, they're not great yet, but they're getting a little better all the time. I like that story, but, or the story could be, we used to have, people were serious about work back in the 60s. So it used to be 90% success, and now we've gone downhill. That's a story. You can start trying to come up with reasons as to why it happened. But to say 65 and 20, 40 years ago, 50 years ago, 65 and 20 today, what's the story there? Story is we don't know what the heck we're doing. Have we been trying new things? Have we been trying new methodologies? Most definitely. We're going to get into that, actually. We're going to look into what different methodologies we've tried over time. Has technology changed? Obviously. Have operating systems become more reliable and more robust and do more things? Yes. Do more people use technology? Should things be more automated? Do we have essentially unlimited, almost free communication today compared to the late 60s, early 70s? Yeah. So the story should be it's getting better. Or maybe it's getting worse because we can't stand the fact that we're not on our phone right now checking our Instagram feed. Maybe, whatever story you want to tell. But to say it's the same is weird. And there's been a lot of research out there trying to figure out why. But yeah, it has been the same. But anyway, let's continue on with this terminology. Systems analysis. This is essentially your requirements gathering. You're looking to understand and specify what this thing should do. Is it an enterprise type of system that's going to run the whole company? Is it a smaller subset of that? Like we've just started interfacing with suppliers in China, and the payment system is manual and it's delayed by 2 weeks, which is affecting our bottom line. Let's create a system that can automate payments to our Chinese business partners. That might be something that the analyst determines that needs to happen. Systems design. So once I have those requirements, I'm going to design a system around that. In the olden days, these were completely discrete steps that were codependent. You do not start systems design until your analysis is 100% complete. And I say olden days, but it still happens to an extent today, this older methodology of doing it. But for a lot of systems, I would say about 2/3 or so, it's more of an iterative process where you do the analysis that you feel is appropriate to a point, you start designing, you maybe even build a prototype system, which then feeds back into your analysis. You see how people use it, you see how that's changed things, so you're gathering more data, and then you have this iterative process that is a little bit more the norm now than was back in the day. So this diagram is right out of the textbook, and I find it pretty funny because this is this beginning of the diagram of the really old school method, the so-called waterfall method that was rigid. And when we had these high failure rates, back in the 60s and 70s, people blamed the methodology. They said it's too rigid. People need more flexibility than that. But obviously that wasn't the only problem. So anyway, systems analysis feeds into system design. So in non-analysis and design words, what we're doing here for software development is, number one, to understand the need. Why are we doing this? What are we doing? Capture the vision. What's the broad scope of what we want to accomplish by doing this? Define the solution. This is where you're designing things and you're saying, okay, this is how we're going to solve the issues that were brought up in the vision. Communicate the vision and solution. This is where all the stakeholders are aware of what the plans are for it. Then build it. Or outsource it, offshore it, buy it. There are other options. But in that traditional view, you'd build it. You'd have your internal team and you'd build it. By the way, my personal theory as to why things haven't gotten better even though they seem like they should have is because of the fact that there are other options. I don't have hard evidence to support that, but if you have a dedicated team that's part of the organization and has a vested interest in its success, you're going to have kind of like a group. Working in school, you're going to have the occasional slacker that doesn't want to work, but for the most part, people want to be successful. That's very different than I'm going to ship it off to a different country that has a different culture and a different way of doing things and a different way of interpreting things. And oh wow, they didn't do this at all the way I wanted them to. Oh, they've got to do it again, and now we're pushed back, and now we're delayed. To me, that seems much more plausible. Or let's talk about the enterprise solution. So there are companies that build giant software systems, like SAS, for example, that they try to deploy as a catch-all solution for every business. That's fraught with problems because every business is different. Even businesses within the same industry are different. Believe me, if you guys say are interested in package delivery, probably a decent business to get into now, and you're deciding to work between UPS and FedEx, so the two big companies, do you think this is going to be an identical experience for you working for either of those? No, definitely not. Very different experience working for FedEx versus working for UPS. They do different things. Even though it appears the bottom line is the same, they're both delivering packages, they accomplish it in very different ways. One focuses on air freight, another one focuses on ground delivery. They do different things better, and they approach technology in very different ways as well. So anyway, moving on. Number 6. Confirm that the solution meets the need. So this is where you're doing testing and you're checking to make sure that you actually solve the problem correctly. And then finally, you launch the solution system. That's also a problematic step because there's always money involved, right? So if it's not quite ready, but the middle manager knows enough about the industry to say, if we can launch it this year, we can make an extra $20 million, and it'll be because of me we made the $20 million, and I'm going to look awesome. Do you think that they're going to push to release it before it's ready? Of course. Of course. You guys ever messed with a beta release of like an operating system or a video game or something and just said, what is this? This should not be out in the wild yet. Those are those types of things. Or beta release is even being too generous because a beta release, at least they're acknowledging it's not ready yet. What about a full release of something that's semi-broken? Yes, I've dealt with that a lot as well. So the methodology that I've referenced several times is called the SDLC, the Systems Development Lifecycle. And it kind of is the same thing of the previous slide, that it was more plain English. This is more defined. So in these steps, these are the generalized steps that are applied in different ways. Identify the problem, and you would get approval for funding and things like that, and scheduling. Plan and monitor the project. Discover and understand the details. This is our analysis, this is step 3. So 1 and 2 are planning. 3 is analysis. 4, very clearly, as it says, is design. System components to solve the problem. 5, build, test, and integrate. This is also called implementation. And number 6, complete system tests and then deploy the solution. So 5 and 6 would be combined into this implementation phase. Now, what I find most interesting is that they've left out the longest phase. The text does not reference the longest phase at all. And the longest phase would be number 7, which is maintenance and security. I think I mentioned last class, my first job was as a COBOL programmer, and the code that I was working on had been in service for 30 years already at that point. I was still working on fixes 30 years after it was initially developed. And they initially took 18 months to build the system. So 30 years, a little longer than 18 months. And by the way, here we are 20 years after that, and they're still using that system. Funny story, in the early 2000s, they thought it would be cool to, and I say cool in like that's actually what they said. They said it would be cool to move away from this antiquated mainframe-based system into a client-server architecture using Java. Wouldn't we be so techie if we did that? And everyone said, yeah, we would. So they invested about $1 billion, with a B, to migrate their system over to this client-server architecture, Java, and they never got it working right. So then they went back to the old system. This took about 2 years, a year to try to switch over to this new system, and then a year to go back to the old system. That was definitely an example of new system failure, new IS build failure. That was bad. That was a lot of money they lost on that. It was so bad that they actually went back to being their own company, because Alltel, back when I was in my 20s, that was one of the major cell phone companies. You know, now it's what, Verizon, AT&T, and then you have a bunch of smaller ones like, not Singular, Boost and whatever, T-Mobile, all these other ones. But back then, one of the big ones was Alltel. So when I'd say I worked for Alltel, they were like, what, you like sold cell phones? I was like, no. The biggest part of their company was actually mortgage processing. And I didn't even know, even though I worked for them, that they had actually bought that from a bank. And it was their most profitable thing. But after this fiasco with their information system, they sold it off. They sold it back to the original bank, so now they're known as Fidelity. This mortgage processing part. So it really affected the business. And have you guys done business with Alltel or think they're a big player in the field anymore? No, they were big. They're like, if I say Verizon right now, you immediately think either Fios or a wireless service or cell phone service. That's what you think. That's what you think if I said Alltel to a group of students, they would immediately think that, oh, they're the cell phone company. You guys are like, I vaguely heard of them, I think, sometime. I don't know for sure. It's because of an IS failure. All right. So this overall project of planning and analyzing and designing, building and rolling out all of that, you need to have a defined beginning and an end. You need to have an understanding of the scope. How much am I doing? You need to push back on scope creep, where it just gets bigger and bigger the more you analyze it and think, wouldn't it be cool if we did these additional things? And understand that we're specifically doing this to develop an information system. In other words, be careful about something called BPR, which is business process reengineering, where you're changing everything about the business. You may never finish. You may end up as one of those statistics of the 65% of failures, because you let the scope get too large. You don't understand there needs to be an endpoint to this, and it's not just this forever ongoing process. It can be a very tempting thing, because you see a lot of possibility in the development. So I've referenced this as well before, some of the major approaches to your SDLC, your systems development lifecycle. And there's the traditional approach, the waterfall approach, which has discrete, defined steps that you're not supposed to move on from a step until you're complete with the previous step. So I don't start analyzing until my planning is 100% done. I don't start designing anything until all of my business requirements have been gathered and planned. I don't start writing any code until I've done all of my design completely. Now, if I'm down, have you guys ever written code that you've kind of planned a little and you get deep down into it and you say, oh, I did not think that through right at all. I got to go back and fix something. Of course that's going to happen. And in the waterfall method, the prescribed action is to halt all activities for whatever phase you're currently in, go back to where the problem's sourced from, and start at that phase again. It's very rigid. You can see why a lot of people blame that particular methodology for the failure rates, because it is pretty rigid. So what the book tends to focus on are these more iterative processes, like the unified process, extreme programming, Scrum, where you are focusing on moving through quickly and building on what you already understand, and knowing that you're going to come back to some form of analysis down the line, and another round of design, and another round of coding, and you're going to continue through with that. I have a couple of videos here. I'm not sure how this is going to work with the streaming to a stream to a screen capture, but let's try it out. This is my test run. Did PowerPoint just crash? Let's see, where were we?
So what is XP? XP is a...
My biggest pet peeve right here. Auto-launching Internet Explorer. That's, I cannot stand. I don't even know if this is Edge or not, because they were very screwy in how they made that transition, so I don't know. But that's right up there with the guy that leaves their high beams on as they're approaching you at night. I mean, that's, oh well. We're just gonna run with it. I just feel a little bit dirty.
Lightweight, humanistic discipline of software development. It is lightweight because it doesn't overburden the developers within a basic process. The process is kept to a minimum. It's humanistic because, as we said, it's centered on people. People, developers, customers are at the center of the process. It's a discipline. As we said, it includes practices that we need to follow. And finally, it's of course about software development. Software development is a key point of the whole matter. In XP, developing is like driving. Imagine having a road, a windy road. We need to be able to drive our car down the road, take the wrong turns, react promptly to changes, for example, obstacles on the road. So in a nutshell, change is the only constant. Eyes always have to be on the road, and it's about steering and not pointing. And XP is trying to do the same thing while creating software systems. In XP, we need to adopt a mentality of sufficiency. What does that mean? How would you program if you had all the time in the world? No time constraints at all. You would probably write tests instead of skipping them because there's no more resources. You will probably restructure your code often because you'll see opportunities to improve it, and you will take them. You will probably talk with fellow programmers and with the customer often, interact with them. And that's exactly the kind of mentality that XP is trying to promote, and agile processes in general. And we will see that following some of the practices that XP is advocating, you can actually achieve these goals, and you can actually behave in this way. And the development process is going to benefit from it overall.
All right. So the book is going to focus a lot on that. I don't know why I don't know if it's crashing or if it's designed to close. It's just odd. Huh. Never had that happen before. Now, my own perspectives on extreme programming. I get a lot of vibes, the same type of vibes I got in the late 90s and early 2000s about Java. What vibes were there back then? Back then, Java was seen as a silver bullet. All of the woes of software development would be fixed because of this magical new tool called Java. That's, by the way, the main motivation that this company had to switch over to this client-server Java-based system, because there's so much hype around it. And in the systems development world, today there's a similar type of hype around extreme programming, agile development. Even this textbook is really focusing on it. I think there's a lot of promise. I think, we talked about this lightweight approach, this humanistic approach that's focusing on people's needs, and it can move around as needed and not get so bogged down in the process like you might in waterfall method. I think there's a lot of promise, but I think a lot of it is an overpromise, particularly when you get to large-scale systems. Because what happens is when you're focused much more on the technology as you would be in extreme programming, you're going to miss the business aspect to it. And that's why we have these information systems being built, is to model the business in a technical sense. Remember, social system technically implemented. So I don't think it's the silver bullet that so many people are making it out to be. But I think there's promise. I think we need some more thought. I think we have really years, if not decades, of research to do on the effectiveness of this approach, and maybe even come up with yet another refined approach down the line. But I think it's an expected and a good development practice that we're going to do in this class. So let's look at Scrum. I don't trust this anymore. Let's see. Let's do it that way. This way we don't have to dirty ourselves in Internet Explorer. We can just do that instead. Didn't I say copy? Copy hyperlink. Wow. That. I think they rushed that aspect of their code out. I don't think they tested appropriately. Okay.
Software is transforming the world.
This is Scrum, obviously,
As
the
it does,
last one on
new
there.
Opportunities arise, creating uncertain risks and rewards. Traditional models of development often focus on efficiency over value and apply processes that just don't work. Projects can run over schedule, over budget, and products may be outdated by the time they are delivered to market. What are you to do? Scrum is the answer. Scrum is used by over 12 million people around the world for products big and small. It all starts with the product owner who represents customers and other stakeholders. The product owner drives the product backlog, a prioritized, dynamic list of all the work that might be needed for the product. Work is done by a self-organizing development team during the sprint, a period of 1 to 4 weeks. During sprint planning, based on the sprint goal, the sprint backlog is created. With the definition of done in place, the development team works together to deliver value. Once a day, the development team meets for 15 minutes for the daily scrum to inspect and adapt their progress toward the sprint goal, and to surface dependencies or impediments. So, who makes sure that Scrum is understood and enacted? The Scrum Master. The Scrum Master is the servant leader of the Scrum team and helps everyone understand Scrum theory, practices, and rules. As the team works towards the sprint goal, the increment grows iteratively, allowing the team to inspect and adapt empirically based on progress. To improve transparency, the increment can be released continuously during the sprint. At the end of the sprint, the Scrum team invites the stakeholders to the sprint review, where they collectively inspect the results. After the sprint review, the Scrum team runs a sprint retrospective, where they evaluate how they worked and build a plan for how to improve. Scrum provides an empirical foundation for teams, enabling them to deliver more frequently, with higher value and better outcomes to customers. Get higher value from your teams and make your customers happy. Visit.
Okay. Let me give you some of my thoughts on this one now. Honestly, it leaves a little bit of a bad taste in my mouth because there is so much corporate jargon in there that I feel like I'm sitting in on an infomercial and I'm trying to be convinced that this is, again, the silver bullet, the solution to everything. Why do you use such weird words? I guess the sprint one, it gives the feeling that there's an urgency to each of these cycles that we're running through, and you're going to quickly develop something. And I get that one, but some of the other ones, now that we know what done means, how do you not know? Okay. Did you have a question or comment?
I was just going to say, Scrum's a rugby term. So they're like basing their whole coding thing around a sports motto, which I feel like is kind of cool.
And in rugby, correct me if I'm wrong, but isn't that where everyone is kind of like fighting for the
You have
ball?
the ball at the beginning.
Right. That doesn't sound very productive to me. Shouldn't we work together? I guess you're with your team, you're working together to defeat the other team. But what's the imagined enemy in my software development team? Is it time? Sorry?
I see time.
Oh, you're right on the same page as me. Yeah, time, I guess, is the enemy. It's just odd. And obviously, Scrum.org would be there to advocate for this particular development process, because then they can make money by sending their consultants out for contracting fees. So they have an incentive to say this is literally the best thing in the world. I don't know. I have and at its core level, I have the same concerns as I do with extreme programming, where I don't believe that it allows you to get in the weeds enough when we're talking about very large scale systems with extremely complicated business requirements. I'm not saying they won't work. I've just done it for a lot of years, and I've seen the types of things that hang you up as an organization, as a team within an organization. I've seen the things that hang you up, and these make me nervous. They make me really nervous that I'm just going to rush through it. And oh, by the way, Scrum is actually, the other thing I don't like about it is that they're a little bit plagiarizing the whole concept. The implication that you guys probably got looking at this is, well, it's a new way of doing things. You know, I appreciate them trying to innovate. No. Back in the 90s, there was a software development process called RAD. Of course it was called RAD. It was the 90s. Kind of like Extreme, that development methodology, also from the 90s. But RAD was an acronym. I guess it wasn't an acronym. It was technically an initialism, right? If you can say the word, it's not an acronym. Isn't that how the rule goes? So like if you say like FBI, you don't say FIBA. You say FBI, that's an acronym. But if you say SCUBA, that's an initialism, even though it's an, anyway. RAD was an initialism that stood for Rapid Application Development, that was designed to have teams that work really fast to get to certain milestones that they've set with defined goal points. You see a lot of similarities between RAD and Scrum. And RAD never took off. And also there was one called JAD as well, which was Joint Application Development, where every meeting had to have every stakeholder in it. You imagine how fun that was. Not. The answer is not. It wasn't fun at all. It was absolutely terrible. I actually was a part of several JAD processes. So, in iterative development, you don't try to build the entire system from the get-go. You build it iteratively. And iterative, of course, if you've done any development, you know just means like a looping process. So I build small portions, and I build on each one as I go through each loop. I might look at what will the interface look like? What will the data storage look like? What about this one use case that I defined during analysis where the client gets paid? Let me build that one portion of this and see if it works. Let me do some testing. That's our iterative development. And then actually maybe even deploy it, you know, if it works well. Agile development, this is a process that emphasizes flexibility to anticipate new requirements during development. So you see people's motivation and their spirit was in the right place when they're coming up with these different methodologies. Because the old methodology admittedly was too rigid. I have some reservations about the specific ones that are out right now because I don't think they allow for deepness. All I think we need to do is define the steps a little bit more, what goes on for this iterative process. But I think it's ultimately a good thing. We need this flexibility to be successful. So these steps that I've identified before, if you recall, there were discrete steps in planning, analysis, design, implementation, so on and so forth. When you think about an agile solution, you're going to focus on certain steps as you go through each iteration more than others. So the very first iteration through, my main focus is on kind of the logistics of everything. Do I have the personnel? Do I have the technology? Do I have the funding? Do we have approval for how long this is going to take? These types of things. You also start to think about, initially, I'm going to touch base with some of the potential users and see, is this something that would work for them? Design a little bit, maybe create a quick structure chart or a data flow diagram or maybe even an entity relationship diagram. Just start to touch on it a little bit. And then maybe build a small prototype in iteration one, a very, very small, limited prototype that represents 1 or to 5% of the entire system. Then you start a second iteration. Now you have most of the data, or most of the planning and the logistics done, so you just might need to go back and touch base with some people for this second iteration, but you should, for the most part, be good to go with it. You also spend some more time monitoring the progress. Are people spending the amount of time I anticipated on this? And now, in the second iteration, I'm going to do a deep dive on what are the business requirements. I'm going to spend a lot of time during the second iteration looking at that. This chart, by the way, is a really good source for test questions. So I would be asking things like, what might the primary focus be during the second iteration? And you would hopefully be familiar enough with this chart to say, okay, during the second iteration, think of a multiple choice test. During the second iteration, let's see, he has here planning, analysis, design, or implementation are my 4 choices for this test. I remember that you really need to be focusing on my analysis during the second iteration. It doesn't mean I don't do design, or I don't do coding, or I don't do planning, but my main focus is going to be on analysis. Third iteration, you're kind of balanced between analysis and design. Fourth iteration, there is a similar balance, but they're decline with an increase in implementation or building of the system. So this is out of the 4th iteration. Again, a type of test question you might see there, what's the primary focus? It would be building for the 4th iteration. And then things start to wind down the 5th and 6th. There's some additional building going on, but I'm not gathering data anymore. I'm not really designing anymore. The planning should be set and done. I don't really need to do much of that. And then during that 6th iteration, I'm really focusing on the rollout. Actually getting it out there, testing it, make sure it does what I expect it to do. So this is a very good and flexible model that I would believe, I haven't seen research, but I would believe would have the highest success rate of all of the solutions that we've talked about. So that's analysis and design at a very broad but not deep level. So what the text does at this point is it kind of goes through an example of a company that's building not an entire information system, but something kind of halfway between an application and an information system. So this Ridgeline Mountain Outfitters, they're a large retail company. They sell clothing, accessories, skiing, mountain biking, so on and so forth. The business processes currently, they started with mail order and phone order. They added some brick and mortar stores, and they most recently have added an extensive e-business component. Here's our catalog. Here's their webpage. As you see, it's very modern. Looks like it could be 2020 webpage right there. Definitely not a late 90s, early 2000 webpage. Only runs Internet Explorer, probably. All right. So what they want is they want a trade show system. So in other words, there's a new business process that they've become involved in that their current information system is not designed to handle. This is smaller. I don't know if I would define it as an app, but that's debatable. I don't take huge issue with the author of the text defining this as an app. I would probably lightly debate and say, no, I think this is somewhere between an app and a full information system, but nonetheless, the text refers to it as an app. Being added to a larger supply chain management system, so they already have a system in place that manages their inventory, their sales, all this thing that goes into supply chain management. Demonstrates one iteration of the small project and assumes more iterations in the total project. We're going to go through all 6 core processes of the SDLC. And we would complete this iteration in 6 days. Next week, you are going to physically do some of these processes in class with feedback from me. I'm not 100% sure how this is going to work logistically, since I know we're all supposed to maintain social distance, but I don't know. We'll sort it out somehow. We'll do our best. If you're ever uncomfortable, though, please feel free to speak up and let me know, because I won't blow that off. I'll deal with it if you're physically uncomfortable. All right. So the problem is that purchasing agents attend apparel and fabric trade shows around the world to order new products from suppliers. They need an information system to collect and track information about suppliers and new products while at the trade shows. So that's what our overall problem statement is. So pre-project. So we've identified the problem, and we've documented the objective of the system. This is our preliminary investigation. Obtain approval to commence the project. So we're going to meet with our stakeholders, including executive management. At this stage, at this very early stage in planning, this is very important because they're the ones that so-called hold the purse strings. They're the ones that will approve or deny a project, and projects always cost money. Time is money. I'm paying people to be here to do things, and if you're going to move them to do something else, it better be worth my while. So you have to make a case for it. You have to argue the case of why this is important. And they'll approve or not approve it depending on how well of a case you make, and then give you a budget. So this goes into some of the detail of the description. Now, I wanted to include this slide. I kind of hesitated whether or not I should spend time on this, whether I should delete it or not, because, I don't know, have you guys ever been told the rules of presentations? Don't have walls of text. That's generally one of the top rules. Don't have walls of text, because what ends up happening is that you end up reading it, which is physically painful for most participants of a presentation. I know for me, I can't stand that. During a presentation, if someone has a wall of text and they start reading it, because my eyes move about 10 times faster than their mouth moves, and okay, so I've read it. You're on sentence 2. Guess I got to sit here and listen to you read it now. But so with all that said, the reason why I did include it, I'm not going to read through it, by the way. I'll just give a gist of it. But the reason why I did include it is because this is a very good example of the type of information you'll have for your business requirements. This is what kind of gets the ball rolling for you to start thinking about what are the use cases, what are the specific events and processes that occur that I'm trying to model, that I'm trying to give a plan for a developer to write the code to do this stuff. So just to see it, again, the gist of it is there's the trade shows, there's stuff that they sell, outdoor clothing and fabrics. They want to capture, the company is RMO, Rich Mountain Outfitters. They want to capture information about suppliers, what they plan to purchase, pictures of the products. Field agents can communicate more rapidly with the home office about suppliers. That's pretty important. So that sentence is showing a process. They want to get all of the data while they're at the trade show, and they want to make sure that people back home at the home office are aware of it in a timely manner, so they can make quick decisions as to what type of business they want to get involved in. So that describes what we're doing, and this is really going to inform you as a systems analyst as to how to move forward. You start to break that down a little bit. The new system should be able to collect and store information about the manufacturer. In my mind, as I'm reading this, I'm already picturing an entity relationship diagram. Again, not familiar with your guys' curriculum. Has anyone built an entity relationship diagram before? Okay, that is something you will learn in here then, because that's a critical modeling element. It's something you normally learn in database. That's why I was asking if you've been exposed to it before. But right now, as I'm reading this, collecting and storing information about the manufacturer, wholesaler, suppliers, immediately in my mind, I'm already picturing an entity relationship diagram. I'm already picturing the entity that's going to store the information about the manufacturer and wholesaler. I'm already thinking about how might that be related to other things. For example, if there's a purchase order, does that relate to the person that you're buying it from? Yes. But that's what you're going to write out in your entity relationship diagram. I'm starting to think about the processes and the permissions of people that have access to this data. and the processes that have access to this data. That first bullet point is all the stuff that starts firing off in my brain, which is what hopefully you guys will get to that point by the end of this class. Collecting and storing information about sales representatives. Again, picture another entity right there. Another key personnel. Collecting information about products. Sounds like something I want to store information about. Taking pictures of products. Oh, now we're talking about the type of information. It's not just text data, it's binary data as well. So that's informing me as I'm reading through this. Now, this quick view is very superficial. And when I'm thinking about building a model, already I'm asking questions. This is where the interview thing, we talk about collecting data, a lot of it's via interview. I'm already thinking of questions as well. For example, do I need to know the name of the wholesaler? Is it important that you're quickly able to have a first name and a last name separate? Do I need to know a phone number, an email address, any other forms of communication, any other forms of identification, any other information at all? Do I need to know the company they're attached to? Some of you may say, well, yeah, but the answer may be no. Maybe it doesn't matter. And if I do need to know the company they're attached to, is that another entity? Well, what about the company's contact information? You see all these different things involves an interview. Seeing these bullet points, this might be iterative session 1. Remember, you're mostly doing planning with that first iteration, and you're starting to do the analysis. This is the type of information you might have from that first iteration of analysis. Superficial stuff, enough to start thinking about it and start thinking about what are my next steps, but not really enough to code the whole system yet. You still need to get a lot more, What's the first one the biggest one in iteration 3? Does anyone remember? That's one I wouldn't ask on a test because analysis and design are very close. It looks like design is slightly nudged, but I would try to make it more on a multiple choice test. That's got to be the worst feeling when you have two answers. One is like 55% right, and the other one is 49% right, and you're like, I don't know how to answer this. I try not to do that because I was a student once too. And I hated that so much when you had those multiple choice things. I would be asking more like iteration 2 or 1 or 4 or 6. Those are the ones I'd probably ask. All right, the business benefits. Increased timely communication between the trade show attendees and the home office, so improving the quality and speed of purchase order decisions. So where does that fit? Is that an analysis thing, a planning thing, a design thing? Where do you think that fits? It's a tricky question, I'll admit. Give it your best shot, I won't judge you. Maybe a bit, because it might show you some of the processes that you have to do. But it might fit a little better in planning, because this is kind of making the case, right? You're trying to get approval from the people that control the money. So you're saying, look, this is good because we're going to have more timely information and we can make better business decisions. Give me my money. Maintain correct and current information about suppliers and their key personnel, thereby facilitating rapid communication with suppliers. Again, I'm making a case. Maintain correct and rapid information and images about new products, thereby facilitating development of catalogs and web pages. I'm making the case. Catching trends more rapidly and speeding up product availability. So this is all I'm making the case. You're right. You could probably use some of this in the analysis, or at least as a starting point to be more familiar with it, to ask more questions. Core process 2, plan the project. Determine the major components that are needed. So supplier information subsystem and a product information subsystem. Define the iterations and assign each function to an iteration. Decide to do supplier subsystem first, and then plan one iteration as it is small and straightforward. Perhaps. I would actually argue against that, but this is where the text is going. I would argue for probably 3 or 4 iterations, but okay. So the work breakdown structure, again, this is in the planning phase. You're trying to determine what you're going to do, understand the details of the problem, design the components, build the components, and perform all system level tests. So you're just kind of writing out what your plan is and how much time it's going to take. And that is about the most optimistic time plan I think I've ever seen. They're essentially saying they're going to plan and deploy this all in like 2 or 3 days. No, most of the time, I think even for a system of this size, in organizations, a very aggressive organization would say a 3 to 4 week schedule. A more moderate organization would probably say 3 to 4 months to do this. So just shy of a week. So-called man hours, if you will. If you have a team of people and you're looking at these hours here and you're assigning them to a team of people, this is 2 or 3 days worth of work here. So all right, this is another part of the planning, the work sequence draft. So this is just where you're showing the dependencies, like I can't start this until I do this, and it falls all the way down to the very bottom where you see perform the user acceptance test. Are people going to find this usable and easy to use? Day 2 activities. This is where we're starting to get into some of the analysis here. Preliminary fact finding to understand the requirements. You're going to be interviewing people, particularly the people that go to the trade shows and maybe the suppliers themselves to see what type of information you can get from them. You start building your use cases. So that's a lot of this class, by the way. Gathering requirements and building the use cases. So what the use cases do is they allow you to formalize this mess of words that the interview data gives you. You're turning that into something where it's a defined set of steps. You're not worried about syntax. You're not worried about, the rules are it has to have, this type of layout. No, you're just describing it in an algorithmic way using your own set of rules. Identify, this is another big issue I have with the text. I don't think they use this word right. Object classes. Can anyone tell me from a programming perspective what an object is? Anyone remember? No pressure if you don't. No one remember? Yeah.
Kind of like a structure, right?
Okay, correct. And what are the 2 main components of that structure? I didn't hear. Oh, I thought you said, maybe it was you.
What was the call?
What, sorry?
I can't remember the answer.
You're walking towards the right answer. You're getting there. No, I think you took one little step back. You was getting there, but okay. So just as a quick refresher, for many, many years, programming was functionally oriented. All that mattered was solving the problem in an algorithmic fashion. That was all that mattered for many, many years. Whatever data was with it kind of came along for the ride. When object-oriented programming was first conceived, they said it's not good practice to have the data come along for the ride. The data should be as well thought out as the process. So we're going to make an object, and an object consists of data and process. Right? Okay. So using the word object here makes me a little nervous because what they're really talking about are groupings of data and data alone, which usually are called entities and not objects. So I take a little bit of issue with that, but we'll run with it. We're talking about the same thing. We're just using different words to describe it. So I would replace identify object class, and I left it up here intentionally because I wanted to address it. So when you guys are reading the book, if you see different words than I'm using, you'd be like, not completely confused. If I just change this to what I think it should be, and then you read the book and you saw something different, you'd probably be confused. Like, I don't know. Should I listen to what he said, or should I do what the book says? So I'm telling you that I'm going to be calling these entities, and the book's going to be calling them something else, but we're talking about the same thing. It's okay. So they've identified supplier, contacts, products, so on and so forth. And they've even drawn, they call it a class diagram, a little bit of an entity relationship diagram here, where you have each entity and how they're related to another entity. So a supplier with contact, they provide the product item, and the product item has a product picture. I even kind of disagree with this a little bit. Normally, binary data types, such as pictures are considered attributes and not their own entity in and of themselves. Normally, unless you have pictures that can be applied to many products, but I wouldn't say that would be the case. Normally, a picture is going to apply directly to a specific product, which means it's an attribute of that product. And when I say attribute, I mean field. We'll get more into that. Day 3 activities. So I think we did this. In-depth fact finding, so we're doing more analysis, understand and document the detailed workflow of each use case, and then define the user experience with screens and report sketches. So here we see some examples of use cases for the supplier information system. Looking up the supplier, enter and update supplier information, look up contact information, enter and update the contract, I don't know. Pretty sure they mean contact information here. And here we see a diagram for this where you see the stakeholders or the actors interacting with these core processes, also known in this case as use cases. And this is important because we start to lay the foundations for the permissions for who can access what. Let's see. We're on 30. All right.